In this course so far, we have looked at a lot of model training and changing of parameters to increase these accuracy of these models. And we have changed, for instance, the number of hidden layers, number of hidden nodes, the kernel, and either increased or decreased the accuracy. So the question becomes, how do we select the best parameters for these models? And in this lesson, we are going to look at this particular problem, and the parameters these are involved for optimizing are called hyperparameters. Let's dive into the code. In this lesson, what we are going to do is find the optimal parameters, which include the number of hidden layers or type of kernel that we used for deciding what weight. Okay, so in this lesson, what we are going to do is look at optimal hyperparameters and how they can be obtained. The weights of the model are the parameters of the model, but there are other parameters like number of hidden layers, type of kernel, etc., that impact what the weights should be or the parameters should be. So these parameters, which are a level above the weights, are called hyperparameters. And it's quite essential that we find optimal hyperparameters, as we have seen before, that they do have a significant impact on the model accuracy. In this lesson, we'll look at how to find the optimal hyperparameters using the example of QM data set with homo-lumo gap as the target value and the support vector regression model. At first, we'll install the required packages, and over here I have already installed those packages, so let me just go to the next cell, which has the code for downloading the dataset. And over here we also process the dataset, get the smiles and gap. I've used the circular fingerprints and featureized it, and also gotten a list like representation of the fingerprints, and then split it into a test, train, and valid dataset. And all of this code is the same from the earlier classical machine learning model or the deep neural the artificial neural networks that we have trained before. And you will see why we need the train, valid, and test split when we are doing hyperparameter tuning, and not just test and train split. There are a lot of packages in Python to do hyperparameter tuning. One of them is Optuna, the other one is HyperOpt. Over here we are going to use Optuna, and this link over here would take you to the documentation page of Optuna, and you can see how to install it or some examples to run. Let's just install Optuna over here, and in the meantime it's installing. Let me tell you what we need to do with Optuna. So at first we'll import all the libraries associated with the model training as well as Optuna, and then we define an objective function, and this objective function should involve training of the model and also validation of the model. Within the code we will also specify what hyperparameters we want and what range we want to scan them to. And finally, once this is ready, we can create the study object that is required in Optuna and then optimize it and find the optimal hyperparameters. And the code below is for SVM, SVR in particular, for the QM9 dataset, right? So we at first import SVR, import Optuna, and the objective function over here has something called trial, and the trial argument is what the thing loops over and finds the best values for them. So here we'll look at the kernel and also the C value for the SVR, and kernel is a categorical variable, meaning it has radial bias function, linear, poly, sigmoid as the values that it can take. So the first part is the name. So we create a variable called kernel which can take these values, and then we create a float. It's because C needs to be between a positive float value. So we just put it between 0.1, which is the lower limit, and 1 is the upper limit for the values that C can take. Once we have set these hyperparameters, we can create the model. As we have is creation, this model is fitting the model to the training and testing dataset, the training dataset, and then we validate the model and get the score. And this score is what the model will try, the Optuna study will try to either maximize or minimize. In this case, we have the score as the R square score for this model, and because it's R square score, we want to maximize it, and that's the reason we create a study object and say the direction in which we want to change the kernel and C values is the direction for maximizing the score. And once we have set that, we can run the optimization, and over here we'll just run 10 trials and see what parameters the model suggests. So you can see it's already gone through 5, 6, 7 paths, and you can see test tried radial bias function, RBF, poly, linear, and it also tried some other values for C, and it has finished 10 trials, and it will show you also which is the best trial. It feels that the best trial is 3 with the 0.36 as the best R square value it has got for this value, for this model. So we can look at the best value and also the best parameters for this model, and we see that its kernel is linear and C value of 0.24, and you can use this value to train the model. As you see, for hyperparameter tuning, we are using the training dataset as well as the validation dataset, and the hyperparameters over here are actually fitted to the validation dataset because that's the score that you're passing over here, and this score is deciding what the kernel and the C value should be. And this is the reason we need a test dataset, so that we are not leaking the data into training or like just cheating in this case, because if we have just a train dataset and a test dataset, we are actually fitting the model to make sure that it gives the best value for the test dataset, right? So that's the reason we try to split it into 3 and keep the test dataset far away from this training or hyperparameter tuning. And once the model and a model is trained, you have the best hyperparameters, you use those hyperparameters and then finally test the code on the test dataset. And that's how you could find whether the parameters that the hyperparameter tuning gave you are really good or not so good. And this is how you would find parameters. You can change the kernel to something, some other value, and get the best parameter it thinks is required to get the maximum or the minimum score that you need.